Students, we are going to now solve question number 3, and this is the diagram. Same diagram I have drawn it here also. So students, what is our observation from this diagram? LM is parallel to CB, and LM is parallel to CB. So some parallel lines are given, and we have got some triangles. Okay. For example, this line is parallel with this. Okay, and this line is parallel with this, and we have got this triangle. This is a triangle, and this is a triangle. This is parallel with this. So we have got triangles and we have got parallel lines. So let us move with the theorem that we have studied before. So theorem 6.1 tells us, okay, we have found another theorem. The theorem says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points. Okay, so if a line is drawn parallel to this to intersect at two distinct points, then the other two sides are divided in the same ratio. So students, we are now going to apply this particular theorem. Okay, that it is going to divide into the other two sides are divided in the same ratio, means AM by MB will be equal to AL by LC. Again, for this particular triangle, LN is parallel to DC, therefore AL by LC will be equal to AN by ND. So this much we know, and we need to prove this one. Okay, so now what we do? We close this one. So let's come back here. So applying the theorem for this triangle A, for triangle ABC, if we apply the above theorem, we can write, since ML is parallel to BC, we can write AM by MB equals to AL by LC, and we mark it as 1. Okay, this much we can write. Now for triangle ACD, what we can write? We can write AN by ND equals to AL by LC. Okay, this much you can write. Okay, students. Now, if we compare equation 1 and equation 2, AL by LC is common to both the equations. So we can write from 1 and 2, we can write from equation 1 and 2, we can write, we can conclude that AM by MB equals to AN by ND. So this much we can do. Now what is being asked in the question? To prove that AM by AB equals to AN by AD. AM by AB equals to AN by AD. Okay. So this again is very simple. Just we'll reverse it now. We write MB, we can write by AM equals to, we can write ND by AN. Now what we can do, we can write MB by AM plus 1 equals to ND by AN plus 1. So this will become equals to, if we take LCM AM, will be in the numerator will be MB plus AM equals to ND plus A of N. Now students, what will be this be? MB plus AM will nothing but just MB plus AM is nothing but AB. So this is AB by AM, and what is ND by ND plus AN is nothing plus this AD by AN. Again we'll write the reciprocals, then just reverse it, it will become AM by AB equals to AN by AD, which is being asked in the question, and this is a required proof. Okay, so students, this was a very simple numerical. Just you to observe that some lines are given parallel, and this forms a triangle. Again, this is a triangle, this is parallel to this. So we apply the theorem and we get this particular equation 1 and equation 2. We got equation 2. So this forms the basis for our proof. Okay, so these are the basis which forms the proof for this one. Okay, so students, what we have learned? We have learned how to apply theorem number 6.1 by observing that this is a triangle and this line is parallel to this, and in this triangle this line is parallel to this. Okay,